Hello dear students, welcome back to my video. In this video, I am going to discuss the chapter Limits and Derivative of class 11, the chapter 13. Okay, let's start. Okay, first we can look limit, the definition of limit. Let y equal to f of x be a function of x. If at x equal to a, f of x takes indeterminate form, then we consider the value of the function which is very near to a. If this value tends to a definite unique number as x tends to a, then the unique number so obtained is called limit of f of x at x equal to a. Okay, this is the definition of limit. Next, consider a function f of x is equal to x square. Okay, observe that as x takes value very close to 0, if x takes the value very close to 0, then value of f of x also move towards 0. Therefore, we can say limit f of x tends to 0 is equal to 0. That is, for this f of x equal to x square, if x equal to 0, then it is 0 square, answer is 0. Therefore, we can say limit f of x tends to 0 is equal to 0. It is read as limit of f of x as x tends to 0 equals 0. In general, we can write as x tends to a, then f of x tends to L, then L is called limit of function f of x. L is called limit of function f of x. It is written symbolically as limit x tends to a, f of x is equal to L. Next topic is left hand and right hand limit. If value of function at point which are very near to a on the left tends to a definite unique number as x tends to a, then the unique number so obtained is called left hand limit of f of x at x equal to a. That is, as x tends to a, there is a particular point at which value of function near to a on the left, that is left of a, there is a definite unique number. This unique number is called left hand limit of f of x at x equal to 0. That is, we written it as f of a minus 0, which is equal to limit x tends to a minus f of x is equal to limit h tends to 0 f of a minus h. This is the left hand limit. Similarly, right hand limit is defined as if the value of function at the point which are very near to a on the right tends to a definite unique number as x tends to a, then the unique number so obtained is called right hand limit of f of x at x equal to a. That is, it is similar to left hand rule. Here, as x tends to a, the value of function at point which are very near to a on the right tends to a definite unique number. That is for left, here right. So we can write it as f of a plus 0 is equal to limit x tends to a plus f of x is equal to limit h tends to 0 f of a plus h. This is the right hand limit. Next, existence of limit. Limit x tends to a, f of x exists if there are two conditions. First, both left hand limit and right hand limit exist. That is, limit x tends to a minus f of x and limit x tends to a plus f of x both exist. That is, if both left hand limit and right hand limit exist, then f of x, limit x tends to a, f of x exists. Next condition, limit x tends to a minus f of x is equal to limit x tends to a plus f of x. That is, if both left hand limit and right hand limit is equal, then limit x tends to a, f of x exists. This is the two conditions for existence of limit. Next, we can look some properties of limit. Let f and g be two functions such that both limit x tends to a, f of x and limit x tends to a, g of s exist. Then we can write first property as limit x tends to a of f of x plus or minus g of x is equal to limit x tends to a, f of x plus or minus limit x tends to a, g of x. This is the first property. Second property, limit x tends to a, k into f of x is equal to k into limit x tends to a, f of x. That is, a constant term is taking outside of the limit. Third, limit x tends to a, f of x into g of x is equal to limit x tends to a, f of x into limit x tends to a, g of x. That is, limit of two multiplied function is equal to limit of individual function is multiplied. Next, fourth property, limit x tends to a, f of x by g of x is equal to limit x tends to a, f of x by limit x tends to a, g of x, where g of x not equal to 0. These are the four properties of limit. These properties are called algebraic property. Next, we can look some standard limit. First one is limit x tends to a, x raised to n minus a raised to n by x minus a is equal to n into a raised to n minus 1. That is, limit x tends to a, x raised to n minus a raised to n by x minus a is equal to n into a raised to n minus 1. Second one, limit x tends to a, sin x by x is equal to 1. Third one, limit x tends to a, tan x by x is equal to 1. Next, fourth, limit x tends to a raised to x minus 1 by x is equal to log a. Fifth one, limit x tends to a raised to x minus 1 by x is equal to 1. Sixth one, limit x tends to a log 1 plus x by x is equal to 1. There are 6 different standard limit. We have to buy at this limit for doing problems. Next topic is derivatives. Suppose f is a real valued function, then f dash of x equal to limit h tends to 0 f of x plus h minus f of x by h is called derivative of f at x. There is one condition: if limit h tends to 0 f of x plus h minus f of x by h exists finitely, then this limit is called derivative. Next, we can look fundamental derivative rules of function. Let f and g be two functions such that the derivatives are defined in a common domain. Then first one, d by dx of f of x plus g of x is equal to d by dx of f of x plus d by dx of g of x. Next, d by dx of f of x minus g of x is equal to d by dx of f of x minus d by dx of g of x. Third, d by dx of f of x into g of x is equal to d by dx of f of x into g of x plus f of x into d by dx of g of x. Next, d by dx of f of x by g of x is equal to d by dx of f of x into g of x minus f of x into d by dx of g of x divided by g of x whole square. These four are the addition, subtraction, multiplication and division of derivative. The addition of two function, derivative of two function is equal to, we have to find derivative of two functions separately and we have to add them. In subtraction also, but for in multiplication and division the equation is different. That is d by dx of f of x into g of x plus d by dx of g of x into f of x for multiplication, and d by dx of f of x into g of x minus d by dx of g of x into f of x by g of x all square in the case of division. Next topic, some standard derivative. First one, d by dx of x raised to n, which is equal to n into x raised to n minus 1. Second, d by dx of sin x, which is equal to cos x. Third one, d by dx of cos x, which is equal to minus sin x. Fourth one, d by dx of tan x, which is equal to sec square x. Next, d by dx of cot x, which is equal to minus cosec square x. Next, d by dx of sec x, which is equal to sec x tan x. Next, d by dx of cosec x is equal to minus cosec x cot x. Next, d by dx of a raised to x is equal to a raised to x log EA. Next, d by dx of e raised to x is equal to e raised to x. Next, d by dx of log ex is equal to 1 by x. These are some standard derivatives. We have to by heart this derivative also, so we can easily solve all problems from this chapter. So this is a chapter limits and derivative. In this video I have included definition of limits and derivative and some of the important formulas for limits and derivative. If you find this video useful, please like, share and comment. Also subscribe my channel. Thank you.